So 7 days and it's still going strong. So here's the cell, and you can see how big the cell is. It's actually not very big at all. But I think I found out what's going on here. So this is actually a larger LED. It draws 20 milliamps, and that there is your average size, just a normal size LED. So as you can see, that's quite large, that one. Now, what I did was I found out what our mystery gunk is, and it is probably 99% silica. So the particle size is less than 80 microns, so it's very fine. It's almost like a clay. Now, it's a waste product from a sand mine, and what they did is they mixed a surfactant with it to make the silica agglomerate so that they could separate it from their water supply, because they recycle their water. So that's got what's called an anionic surfactant. The anionic surfactant is actually bound by a copolymer, so it's very, very stable actually. So what that means is, what I did was I got some of the water which had the anionic surfactant and mixed it with potassium hydroxide, which has positive ions, which is an ionic liquid. So basically we've got negative and positive, a very loosely bound positive ionic solution, and a very, at this stage, a weak anionic copolymer bound solution mixed in one. And that's what I've got going on in here, and that's why it's a recyclable battery. So going behind the scenes, here's one I've got going as well, just a little one, and this is copper and zinc, and I've tried all different methods, and all of them work, and they're all rechargeable. So if you want to look all that up, you can, but this is probably a first as far as mixing a strongly bound anionic solution with a loosely bound ionic solution all in one. And that, I think, in combination with the particle size of the silica, which, if you like, we use that as in our battery, so that actually worked as a structure to hold the solution, the electrolyte solution, and meant that it could hold the charge within the thickness of the layer that we put into the battery, and that's why it's lasted so long. I don't know how long it's going to last, but if you calculate it out so far at 20 milliamp hours for a week, it's easily a 2.5 amp battery. At the least, it's 2.5 amps been taken out of there so far, which is pretty phenomenal. So I hope you have enjoyed this video, and I'm really interested in what you've got to say about that. I'll catch you on the next one. See ya.